coding. Okay, so let me share the screen. I think the screen is visible to you guys now, right?
Yes, sir.
Okay, so in our previous lecture, we were studying some basic about the vector, how to add them and components of vector. Today we are going to start with multiplication of vector. Okay, so today we're going to start with multiplication of vector. That is how to multiply vectors. So there can be two different types of multiplication. One is like you can multiply a vector with a scalar quantity. You can multiply a vector by a scalar quantity. For example, A is a vector. Like, let me write it here. A is a vector. Okay, small a is a vector, and this is defined as like 2i, 3i plus 5j. Okay, and then what I want to do, I want to multiply it by a number. So it's a vector quantity. My vector quantity is this one. This is my vector, and my scalar quantity is like my scalar is like scalar quantity is like maybe let's say s. S is a scalar quantity, okay, and the value of this is maybe 7. Okay, 7 is my scalar quantity. And now what I want to do, I want to multiply this scalar by vector, right? So now what I want to do, I want to multiply s with a vector a. So this is like, so now put the value of s here. The value of s is a, and a means 3i plus 5j. So in this kind of multiplication, you have to do the normal multiplication. Just simply multiply this thing. 7 times 3i plus 7 times 5j. Okay. So this is basically 21i plus 35j. Very easy. In case of multiplication of vector by a scalar quantity, you don't need to, there is no special rule here. কোনো rule নাই, just simple multiplication. Simply আমরা যে multiplication গুলো করি সেটাই হবে. And same thing can be applied for division. For example, now let's talk a little bit about the division by a scalar. Okay, so what I want to do, I want to divide vector a by vector s. So that is, I want to divide vector a by s. This means this is very easy. This is basically equal to vector a multiplied by 1 over s. Okay, that's the thing. So 1 over s, that means now my vector a is equal to this one, 3i plus 5j multiplied by 1 over s. 1 over s means 7, right? So this is basically then 3 by 7i plus 5 over 7j. So this is how you can multiply or divide a vector by a scalar quantity. Okay. So in case of multiplication, just simple multiplication. And if someone asks you to divide a vector a by a scalar s, that means you have to multiply a with 1 over s. This is the rule. So this is really very easy. But in today's lecture, basically we will put our concentration on multiplying a vector by a vector. That is vector multiplication. We want to multiply a vector by another vector. That's the thing that we want to discuss today. So, and there can be two kinds of multiplication. One is called scalar multiplication, and the other is called vector multiplication. Okay, so there can be two kinds of multiplication. Okay, so one is vector and there is scalar multiplication. So this is the main focus of today's lecture. Okay, vector multiplication. So there can be two kinds of multiplication. One is called scalar multiplication. Scalar multiplication. So what is scalar multiplication, by the way? Let's say I have two vectors. Let's say we have two vectors. One vector is A. A is a vector, and B is another vector. Okay. B is another vector, and we want to multiply them. We want to multiply them, and the angle between them is, for example, theta. So the scalar multiplication between two vectors A and B can be represented as A dot B. Okay. If you multiply two vector by scalar multiplication, in that case we put a dot sign here, and by multiplying them the result should be A, B, and the cosine of angle between them, cos theta. So look here, in this case, in this kind of multiplication, if you multiply two vector quantity, the product is a scalar quantity. And that is why it is called scalar multiplication. That is, we are multiplying two vector quantity and the result is a scalar quantity. Here, A and B, by the way, are the magnitude of vector A and magnitude of vector B, and theta is the angle between them. So in this case, the vector, so the product means product of two vector is a scalar quantity, okay, and that is why it is called scalar multiplication, since the product is a scalar quantity. And also oftentimes we call it dot product, it is also called dot product, okay, dot product, or someone say dot multiplication. It is called dot multiplication or dot product because we are using a dot sign here, that is why. So dot multiplication or means scalar multiplication, okay. Dot multiplication means scalar multiplication. And a real life example of this is like work. A real life example of this is, for example, work. Work is basically a multiplication of, in normal sense we say work is equal to what? Can you say what is that? We call it is, okay, force times distance or displacement, right? Basically, work is a multiplication of force and displacement. But you have a look here. Force is a vector quantity and displacement is a vector quantity, and we are multiplying them. So basically, to derive work, force, the multiplication between force and displacement is a dot multiplication. Force dot displacement. So in other words, we can say W equal to force dot displacement. If I say displacement as D, force dot displacement. Okay. So this is how we can define scalar multiplication. So this is how scalar multiplication look like. So I want to move a little bit forward with the dot multiplication. Okay. So now using dot multiplication basically has some application. Like by using dot multiplication, what I can do, I can find out the magnitude of a vector. I can find the magnitude of a vector. So before that, I want to do some more exercise. So let's say we start with like multiplication of two vectors. No, not dot multiplication. It should be like dot multiplication or scalar multiplication of two vectors. Multiplication of unit vector. Okay. Scalar multiplication of unit vector. We know there exist three unit vectors. They are I, J, and K. I is a unit vector along x direction, right? And J is a unit vector along y direction. Okay, so J is a unit vector along y direction, and K is a unit vector along z direction. So these are the three well-known dot unit vector, and now I wanna I wanna multiply this unit vector. For example, I wanna multiply I with I by a scalar multiplication. That's I dot I. By the way, what is the value of I? What is the magnitude of I? The magnitude of I is 1. Magnitude of I is 1, right? So আমরা একটু আগে দেখেছি যে like if you multiply two vector A and B, then the result would be magnitude of A, magnitude of B, and the angle between them. So I dot I will be equal to magnitude of I is 1, and the second vector magnitude of this I is also 1, and cosine of angle between I and I. What is the angle between I and I? I is always along x direction. So your first I is along x direction, the second I is also along x direction, right? So
Sir, 0
angle
degree.
between them is 0. And cosine of 0 means 1. So 1 times 1 times 1, that is equal to 1. Okay, so I dot I equal to 1. And same thing will happen if you multiply j dot j or k dot k. Okay, that means I dot I or j dot j or k dot k equal to 1, right? This is the one thing. And second thing is I want to multiply I with j by a dot product, I dot j. Same again, the magnitude of I is 1 and magnitude of j is also 1, and the angle between I and j. What is the angle between I and j? I is along x direction and j is along y direction. The angle between them is 90 degree, right? So 1 times 1 into cosine of 90 degree, and by the way, cosine of 90 degree equal to 0. So that is equal to 0. So I dot j equal to 0. Similarly, you can say I dot k equal to 0, and also you can say j dot k equal to 0. Okay, so that means if you multiply a vector, a unit vector with the same unit vector, the result will be 1. And if you multiply a vector, a unit vector with another unit vector by scalar multiplication, the result will be 0, such as I dot j equal to j dot k equal to k dot I equal to 0. Okay? So this is the the result. So I mean, I can like summarize this way: I dot I equal to j dot j equal to k dot k equal to 1, and same here I dot j equal to j dot k equal to k dot I equal to 0. This is the formula that we need to remember. Okay, now we want to multiply. I want to multiply two general vector, two vector in general. I want to multiply two vector in general. That is, let's say, or say like a scalar multiplication of two vector. Multiplication of two vectors. Okay. Let's say I have two vectors. One is A, that is defined as AXI, AYZ plus AZK, okay, plus AZK. Here AX is the X component, AY is Y component, and AZ is Z component. And the other vector is B, which is defined as BXI plus BYZ plus BZK, okay? And I wanna multiply them. I wanna multiply them by a dot product. Now A dot B is basically equal to this guy dot this guy. So AXI plus AYZ plus AZK, right? And then this is a dot product here. BXI plus BYZ plus BZK, okay? So I want to make this product. And in this case, what I have to do, at first I have to multiply this guy with all of them, okay? That is AXI multiplied by BXI plus BYZ, BYZ plus bzk, and then plus same thing you have to do for this guy, ayz multiplied by this one. Okay, I'll do this one later maybe. Now you see here ax and then I multiply by this one, that is ax bx. Okay, I have to put the dot sign here, by the way. I dot I plus ax. I have to multiply this one with that one. So ax by I dot j. See here, আমি কিন্তু এটা লিখছি না যে ax dot by, because ax by these are simply number magnitude. Okay, so it doesn't matter, and plus ax bz I dot k plus maybe. Okay, I mean, let's have a look at this guy here. So I dot j equal to what? I dot j equal to 0. So this guy will be 0. And here again, I dot k equal to 0. This one will be 0. So this only this one will survive from the first term. And second term, we can do like this one. I can multiply this with this thing. Dot bxi plus byz plus bzk, and then plus third one azk dot product of bxi plus byz plus bzk. Okay, this is the thing I have to do. So now have a look at here. J dot I equal to 0. So this term will become equal to 0. J dot j equal to 1. So this will survive. This will give you ay by, and j dot k here again 0. Same thing for this third term. Az k dot I 0. So az bx will be equal to 0. K dot j is again equal to 0. So az by will be equal to 0, and k dot k equal to 1. So only one term will survive from here. That is az bz. So finally, we can write a dot b equal to ax bx, I dot I equal to 1. So I can write like, and then plus ay by plus az bz. So this is the value of a dot b. This is the value of a dot b. Like if I have a vector like a equal to axi plus ayz plus azk, and vector b equal to bxi plus byz plus bzk, in that case, the dot product between them, a dot b equal to what I have to do? I have to multiply just the x component of the two vector ax bx plus y component of the multiplication of the y component of the two vector ay by plus multiplication of the z component of the two vector, that is az bz. Okay, so this will give me the dot product of two vectors. So to clear the concept, we can try a math. We can try a math to clear our concept. Okay, so let's try a math here. So let's say we have two vectors. Let's say we have two vectors. One is vector A means 3i plus 5j plus 7k, and vector B equal to 2i minus 3 minus, no, let's keep it easier, minus 4j, minus 4j plus k. Okay. Then what should be the value of a dot b? So the value of a dot b would be, to find the value of a dot b, what I have to do? I have to just multiply the coefficient of I, right? 3.2. This is ax bx 3.2 plus 5 dot, the coefficient of z is minus 4 plus coefficient of k is 7 multiplied by 1. So this is basically equal to 6 minus 20 plus 7, that is equal to minus 7, right? Clear? Clear, guys? So this is how you can find the dot product of two vectors. Now, what I'll be doing now is I will use the idea. I will use this idea to find the magnitude of a vector. So now I want to see how to find the value of a vector or find the magnitude of a vector. Let's say I have a vector. Let's say I have a vector like this. Let's say I have a vector like this. Let's say we have a vector. Vector. It is like A. So A equal to AXI plus AYJ plus AZK. Okay, this is a vector. A is defined as AXI plus AYJ plus AZK. And what I want to do, I want to find the magnitude of A. We want to find out the magnitude of A. Magnitude of A, or that is like absolute value of A. Okay, magnitude of A. This is what I want to get. Now, to do so, or to get the magnitude of A, let's take a dot product of A with A. Okay. So now, to get this thing, what I have to do, I have to take a dot product of A with A. Dot product of A with A means what?
1.
A of A equal to 1. Is that okay? Let's see. Let's try it this way. A means like AXI. Need to calculate. Let me write it in this way. A dot A means magnitude of A, right? Times magnitude of A, right? Magnitude of this A is A, magnitude of this A is A. And the angle between this vector is what? A, for example,
0 degree.
0 degree, right? So this is cosine of 0. And cosine of 0 equal to what? 1. And magnitude of A means A square. Magnitude of A whole square. So let me tell it named as equation number 1. Okay. Also again, A dot A equal to what? Let's say we can use this formula. See here. Let's use this formula. So we know A equal to, let's write this here. A means AXI plus AYJ plus AZK, right? And same again, the next A is the same vector. That means vector A equal to AXI plus AYJ AYJ plus AZK, right? So now what I have to do, A dot A means what? AX BX. So here your AX is AX and BX is this guy. So AX BX means AX square, right? Plus AY BY, that means AY times AY, right? So that is AY square plus AZ square. Clear? Is it clear to you guys?
Yes, sir.
Okay. So now see here, in both cases, okay. In both cases, the left-hand side is same. In both cases, the left-hand side is same for equation 1 and 2. So we can say that the right-hand side are also same or equal. So we can say A modulus square equal to AX square plus AY square plus AZ square. So what I can say, okay, vector A or magnitude of A is basically equal to AX square plus AY square plus AZ square. So this is the formula to find out the magnitude of a vector quantity. Formula to find the magnitude of vector quantity. Okay. Okay. So this is how we can find the magnitude of a vector quantity. What is the technique? Technique is the magnitude of a vector equal to x component square plus y component square plus z component square, and then I have to take the square root. Okay, so x square plus ay square plus az square, and I have to take the square root. And solving a math will definitely make our concept clear. So let's say a vector is defined as, let's say vector is defined as a vector is defined as 3i plus 4j plus 5k, for example, right? So, and then its magnitude A will be equal to what? Magnitude of this vector will be equal to ax means 3, that is 3 square, plus ay is 4, plus 4 square, plus az equal to k, 5, that is 5 square, right? So 9 plus 16 plus what? 25. So that is means 50, which is, by the way, 5 root 2. Okay, so this is the magnitude of this vector. Clear, guys? Is it clear to you?
Yes, sir.
Okay. And then the next thing that I want to discuss with you guys is how to find the angle between two vectors. How to find the angle between two vectors. Okay, so angle between two vectors. Okay, so this should like angle between two vectors. So let's say I have two vectors. Okay, let's say I have two vectors. One is A. This is vector A, and the other vector is B. And the angle between them is theta. Okay, and I want to find the angle between them. I want to find the angle between them. So let's say two vectors are A, that is equal to ax I plus ayz plus azk. This is a vector, and the other vector is B, which is defined as bxi plus byz plus this is like k. Okay, these are the two vectors, and the angle between them is theta. Angle between them is theta, and we want to know the value of theta. Okay. And to get the value of theta, what I have to do at first, I have to take a scalar product of A and B. So now, so what I have to do, I have to take the scalar product of them, A dot B. A dot B equal to what? I know Y dot B means AX BX plus AY BY plus AZ BZ, right? AX BX plus AY BY and times AZ or plus AZ BZ. Okay, this is the uh, scalar product, and A dot B, actually A dot B means, by definition, A dot B means magnitude of A times magnitude of B times cosine of theta, right? So this guy equal to AX BX plus AY BY plus AZ BZ, okay? Clear? That means cosine of theta is equal to AX BX plus AY BY plus AZ BZ over magnitude of A times magnitude of B, right? So look here, you know the value of AX, BX from here. The value of AX, AY, AZ, BX, BY, and BZ is given here. And also from here, you can easily find the magnitude of the vector A and B by using this formula, right? Using this formula, right? So here, or I can write it here explicitly that magnitude of A means square root of AX square plus AY square plus AZ square, and magnitude of vector B is equal to bx square plus by square plus bz square. So finally, I can write like cosine of theta. No, I know, as I know what I have to find. I have to find the value of theta. So value of theta is basically equal to cosine inverse of ax bx plus ay by plus AZ, BZ. And then in the denominator, you will get like AX square plus AY square plus AZ square multiplied by magnitude of B is this guy, BX square plus BY square plus BZ square. Okay. So this is how you can find the magnitude of a uh, uh, or this is how we can find the angle between two vectors. Okay, so let's try math. Let's try math. That will make the concept more clear, right? So let's try math. Which math? Let's see. I have a list of maths here. So let's try this one. No, not this one. This is not a kind of easy kind of math. Okay, so here, see here, math number 41. Math number 41, here they are saying, okay, a vector is defined as, use this formula to calculate the angle between two vectors that is given by A equal to 3i plus 3j plus 3k and B equal to 2i plus 1j plus 3k, okay? So two vectors are given here. Two vectors are given here. Vector A is 3i plus 3j plus 3k and vector B equal to 2i plus 1j plus 3k. And what I have to do, I have to find the angle between these two vectors. Clear? So let's solve it. So solution. So let's say the angle between them, let's say the angle between them is theta. So since the angle between them is theta, we can write, theta cosine theta equal to A dot B divided by magnitude of A times magnitude of B, right? We can use this formula. Cosine of theta equal to A dot B divided by magnitude of A times magnitude of B, like this one. You see here, from here, cos theta. AX, BX, AY, BY, AZ, BZ means A dot B, okay? So, is it clear to you or you want me to write more? Guys, it's শব্দ করতে হবে. Is it clear? Can you
Yes,
hear?
sir.
No, it's fine. Thank you. And now see here, let's say A equal to vector A equal to 3i plus 3j plus 3k. This is my vector A, and then vector B is basically equal to 2i plus 1j and then plus 3k. So A dot B equal to what? Oh, by the way, my vector was like small a, small b, okay? So let me write it like this way, small a, small b. So this should be basically small a, right? Small a. So A dot B will be equal to AX BX, that's 3.2 equal to 6 plus 3 times 1 equal to 3 plus 3 times 3 equal to 9. So 9 plus 9 equal to 18. And magnitude of vector A is equal to the square root of 3 square plus 3 square plus 3 square. 3 square plus 3 square plus 3 square. So there is square root of 27. Right? 9 plus 9 plus 9, 27. And vector B, magnitude of vector B is 2 square plus 1 square plus 3 square. So this is basically equal to 9 plus 1, 10, 14. So cosine of theta equal to A dot B means 18, and magnitude of A is square root of 27, and magnitude of B is square root of 14. So theta basically is equal to cosine inverse. Guys, do you have a calculator with you? Any of you?
Yes, sir.
Can you
Yes,
calculate
sir.
it and find the value for me, please?
Sir, the value is 22.02.
22.02. So let's say theta equal to 22.02 degree. So this is how we can find the angle between two vectors. So and now Let's go back to the theory part once again. We already told you guys that, okay, there exists two kind of vector product. One is scalar product and the other one is like, uh, so one is a scalar product and the second one is vector product. You can multiply two vector by two way. One is by scalar way and the second one is vector way. In case of vector product, the product is a vector. For example, I have two vector. For example, let's say I have two vector. One is A and the one is B. Okay, so I have two vector. One is vector A and the other one is vector B, and the angle between them is theta, and I want to multiply them. So in case of vector product, if we multiply A and B, the product will be a vector. See here, in your previous case, in case of scalar product, we multiply two vector and the resultant was a scalar quantity. But in case of vector product, if we multiply two vector, in that case, the resultant is a vector quantity. Okay, and that is why it is called vector product. Okay, so in vector product, in case of vector product, the product is a vector quantity like this. And if A and B are two vector and the angle between them is theta, we can write A cross B equal to A times B, this is the magnitude of A and B, and multiply by sine of angle between them, A, B sine theta. And see here, A and B both are scalar quantity and sine theta is also a scalar quantity. And what I wrote here, or I say here that if we multiply two vector by a scalar quantity, or sorry, if we vector multiply to quantity, the resultant would be a vector. So I have to multiply this with a unit vector. Let's say the unit vector is R. Let's say the unit vector is R. So, and this guy R here, this will not change the magnitude because its magnitude is 1. If you multiply anything by 1, magnitude will not change. It will just show you the direction. It will just show you the direction of the product. Okay, so the multiplication of two vector A cross B is equal to magnitude of A times magnitude of B times sine of angle between them multiplied by a unit vector, where R is a unit vector. And unit vector in the direction of the product. Okay. Or unit vector. And by the way, this product, this multiplication is also known as cross product or cross multiplication. See, we are using a cross sign here, okay? That is why sometimes we call it, okay, this is a cross product, or it is named as cross product or cross multiplication, okay? So this is the definition of cross product. And now, how to find the cross multiplication of two vectors? Okay, and then let me tell you. So, okay, and the second thing is let's say I have two vector. One is A and the other vector is B. A vector and B vector. And then I want to multiply A with B, A cross B. Let's say I'm doing A cross B and the resultant is R. R is a vector. And what should be the direction of this R vector? What should be the direction of the vector R? The direction of the vector R will be perpendicular to A and B. The direction of R, again, I'm saying the direction of vector R will be in a direction that is perpendicular to both A and B. Right? For the time being, it's okay. And then now, what I want to do, I want to multiply, cross multiply to unit vector like I cross I. I cross I equal to what? Again, uh, just have a look at the definition. A cross B means magnitude of A times magnitude of B times angle of sine of theta, sine of the angle between them, multiplied by a unit vector. So I dot I is equal to what? I cross I. 1 multiplied by 1, and then sine of angle between two vector is 0. That is equal to 0. So same again, I dot I equal to 0, j dot j cross j equal to 0, and k cross k equal to 0. Right? So if you cross multiply two similar vector, this will give you 0. And now what if I multiply I with vector j? I cross j. Magnitude of I is 1. Magnitude of j is also 1. And angle between I and j, let's say this is my vector I, and this is my vector j, and this is my vector k. Okay. Angle between them is what? Angle between I and j is
90 degrees.
90 degree. That is sine 90 degree. And you have to do what again? You have to multiply this thing with a unit vector. With a unit vector that is perpendicular to both of these two vectors. And a unit vector that is perpendicular to I and j is k. A unit vector that is perpendicular to I and j equal to k. That should be actually k. Oh, no, I should not put cap on top of this. So 1 times 1 and sine 90 equal to 1 again. So that is 1 times k, that is equal to k. So I cross j will give you a k. Okay. And similarly, j cross k will give you I, and I cross, no, this k cross. Same again, k cross I will give you a j vector. Okay. So this is the formula for, or this is some identities that you get when you multiply two unit vectors. And now I'll tell you how to multiply two.
Plus, I should be minus j vector because it's anti-clockwise.
K cross, this k cross I is j. You check yourself, okay? K cross I equal to j. Okay. K cross I. Okay. And then let me tell you how to multiply two vector that are written in a component form. Okay. Let's say we have two vector. One is A and the other one is B, such that so it's like, let's say we have two vector like this, A equal to AXI plus AYZ plus AZK, okay? And the other vector is B is equal to BXI plus BYZ plus BZK, okay? And then what I want to do, I want to multiply them. I want to make a vector multiplication between them. That is, I want to do A cross B. So to get the value of A cross B, what I can do, I can, to easily get them, I can do like use the determinant technique, like I, J. Are you guys familiar with this technique?
Yes, sir.
Okay, yeah, that's it. So AX, BX, no, AX, like AY, coefficient of J for A is AY, and coefficient of K is AZ for vector A. And same for vector B. So this should be like BX, BY, and BZ. Okay. Is it okay with you? And then I have to find the determinant. That's it. So this is basically equal to I. When I considering I, for I have to take these two guys. This one. This thing. Okay. This circle. That is AY BZ minus AZ BY. Right? And then for J, I have to say minus J. So in that case, I have to just don't consider this line and that one. These two, ax multiplied by bz, bx multiplied by az. Ax bz minus az bx. Okay, and then lastly for, let me delete this one first. For k, same again for k, what I have to do, I don't need to consider this one and along this line. Okay, so I left with this thing. So that is like k plus k, ax by multiply ax with by. So ax by this correct minus ay bx. Okay, so this is basically a cross b. So this is how you can find the value of, or you can find the vector product of two vector, or you can, I can say this is how you can find the product of two vector quantities. Okay, so let's try a math. To make our concept clear. Okay, so the math is like this. Okay, same again. We have two vector, a equal to 3i minus 4j, and the other vector is minus 2i plus 3k. Okay, and what is the vector c that is equal to a cross b? Can you see this thing? দেখতে পাচ্ছ? A vector a equal to 3i minus 4j, and the other vector b is minus 2i plus 3k. So when I'm writing this thing, that means two vector is given to me. One is a equal to 3i minus 4j, and the vector b is basically equal to minus 2i plus 3k. And I have to find out the value of a cross b. What I have to find? I have to find out the value of a cross b. This is small b. Small b. A cross b. And to find the value of a cross b, what I'll be doing, I have to put them in a vector. And look here, I, j, and then k. Let's do one thing first. Let's rearrange this guy. Here I have I, j, and here I have only I and k. So what I can do, I can write 3k. Let me write it this way. Plus 0k. That means coefficient of k is 0 here. And for this one, you have no j here. So that means plus 0j, right? And then plus 3k. So just put the value here. For a, just 3i minus 4j plus 0k. And for b, it is like minus 2i plus 0j plus 3k, right? And apply the same formula here. Like for I, it would be like this one and this one. I just have to consider this guy. Right, okay, this one. Multiply this with this and this with this. So 4 minus 4 times 3, that is equal to minus 12, minus 0 times 0, that is equal to 0. And then plus minus j. For j, I don't need to consider this one and this one, right? So 3 times 3, that is equal to 9, minus 2 times 0 equal to 0. And then k. Same again for k. For k, I don't need to consider this guy and this guy here. So plus k, multiply 3 times 0, that is 0, minus 4 times 2, minus 4 times minus 2 equal to plus 8, so minus 8. Okay, so this is basically equal to a cross b, which is basically c, by the way. C equal to a cross b, which is equal to minus 12 minus 0, is minus 12y, and then minus 9j minus 8k. Okay, so I can say like vector C equal to minus 12i minus 9j minus 8k. Okay, this are the this is how we can find the cross product of two vectors. And clear? Is it clear to you guys?
Yes, sir.
Okay.
Yes,
And
sir.
then here there are a few other maths here. I think you will be able to do it by yourself, like number 36 or number 37. Since I'm running out of time, I am leaving this for you guys. And there are some homework. There's some homework that you have to do, like 41, 40, 37. This is written here, like 36. Okay, this is the math. These are three problems that you have to do at home. Okay. And this is the math that you have to do at home. And let me stop the recording.